Okay, 2012 question 6. Basically, this is a particle motion problem. It talks about a particle that's moving along the x-axis. So this particle can move either left or right. Just keep that in mind, okay? Part A. When is the particle moving to the left? Okay, so a particle will move to the left when the derivative is negative. Okay, derivative in this case is velocity. So what we want to do is we want to make a sign chart. We want to set v of t, which is equal to 0. We want to set that equal to 0 now. So a little bit of a trig review. Cosine will come out to 0, and you want to look at your unit circle if you forgot. Cosine will come out to 0 at a few moments, at pi over 2 and at 3 pi over 2. Okay, so to solve for t here, we're actually going to divide by pi over 6 for each of these. And if you guys divide by that or multiply by the reciprocal, you should get 3 and 9. Pause there, make sure that you guys understand that before you move on, okay? So here we go. I have a sign chart. I have 3, I have 9, okay? So you want to plug it into your v of t now. So I'm going to pick some values here, and I'm going to strategically pick it, okay? So I'm going to go ahead and pick 0. I'm going to go ahead and pick 6 and 12. Now, some people might have picked 0, 4, and 10. You're more than welcome to do so, but take a look at why I use these values. If I plug it in, I'm going to get the cosine of pi over 6 times 0. Cosine of pi over 6 times 6. And the cosine of pi over 6 times 12. Now, I did it so that it conveniently comes out to the cosine of 0, the cosine of pi, and the cosine of 2 pi. Those angles I know right away. Cosine of 0 is going to be a positive 1. Cosine of pi is negative 1. And cosine of 2 pi is positive 1. Okay? Pause there. Make sure you guys understand those values first. So basically, we know the particle is going to move to the left when the derivative came out negative. So in this case, it's from 3 all the way to 9. And that's it. Part B. Write but do not evaluate an integral expression that gives a total distance. Okay, total distance. Remember, total distance is different from displacement. So if you want distance, you have to integrate speed. Speed is the absolute value of v. That is basically it. You're going from 0 to 6. That's a straight one-pointer. Very quick to do. Takes a few seconds if you just know what total distance is. Okay? Part C. Find the acceleration at part time t. And we'll pause there and we'll answer the second part afterwards. Okay? So we have v. We know that v of t is cosine of pi over 6t. To find a, we have to take the derivative. This right here is going to involve a chain rule because there's a function, pi over 6t, inside of the cosine function. So it's the derivative of the outside of the same inside times derivative of the inside, which is pi over 6. Okay? That is your acceleration. You can leave it right there. The scoring guidelines scooted the pi over 6 in the front. That's fine too. Now they're asking you, is the speed increasing or decreasing? Remember, if you want to know if speed is increasing or decreasing, you need to know two things. You need to know whether the acceleration and velocity are going to share the same signs. Okay? So you plug in 4 because that's the time that we're interested in. So if you plug in 4 into acceleration, you're going to get this. Okay? Now, you do have to know a little bit about it. Sine of 2 pi over 3. 2 pi over 3 is in the second quadrant. Okay? I know that because 2 is less than 3, and that was kind of the rule for the angles in quadrant 2. Now, I know that sine in quadrant 2 always comes out positive. You don't have to know what the actual value is, but you do have to know what the sign is. So I know that this whole thing, a positive times something negative right there, I know it has to be less than 0. Okay? V of 4, if you plug it in, you're going to get the cosine of 2 pi over 3. Again, we're in the second quadrant. Cosine in the second quadrant, I know is negative because all students take calculus. Okay? So we now know that acceleration and velocity comes out both negative. So what does that mean? Since they share the same signs, I know that the speed is increasing at t equals 4. There you go. Last one here, find the position. If you're given velocity and you're wanting position, you have to integrate somehow. So, what you do, let me start off here so we have a little bit of space. What you want to do is you want to integrate v of t. So here's the thing. You want to integrate v of t, but from where to where, right? You want to know you want to have 4 as one of your bounds. Now, what's the other bound? What's the other bound? So, if you read in the text, they give you another condition. The position is that x equals negative 2 when t equals 0. So you want to use that same time here. So in this case, we're actually going to go from 0 to 4. Okay, but what you have to consider is, this is just the accumulation. Well, where did you actually start from? Remember that example, if you move 5 spaces to the left, that doesn't mean you're at negative 5. It depends on where you started, right? If you move 5 spaces to the left, you're moving 5 spaces to the left from somewhere. Now that somewhere is where x of 0 is. At time 0, you guys were at negative 2. So pretty much this is what we have right here in the scoring guideline. Okay? This is where we started. And this is how much we moved. Okay? So here, this is going to involve some integration. You could actually use mental use substitution here, since there is a function inside of another function. If you take a look at this highlight, the derivative of pi over 6t is just pi over 6. The reciprocal is 6 over pi. Okay? Now the integral of cosine is just sine, and the inside stays the same. Okay? And then you evaluate. They actually plugged everything in. I would probably just do negative 2 plus, and then this is where you write in your work, 6 over pi sine of pi over 6 times 4 minus 6 over pi sine of pi over 6 times 0, and I would just leave it there. Okay? Equal is equal, you get your answer there, right? And that's it.